Alright, so last class we talked about 6.3 trig functions of angles, and we talked about how theta had to be in standard position, which means it's on the x-axis and it's kind of looking like a triangle like this, and here is our theta, and the distance is going to be on the x-axis and the y-axis, and then the radius is our hypotenuse. We talked about how x squared plus y squared equal to r squared, and how we could solve for r by taking the square root of both sides. And we reminded ourselves of sine theta equals y over r, cosine theta was x over r, and tangent theta was y over x. We had to be careful that x didn't equal to 0. And then the cosecant, secant, and cotangent were the reciprocals of those. We also reminded ourselves that we could remember the signs of what was happening by all students take calculus. So all were positive. Sine is positive in quadrant 2. Tangent is positive in quadrant 3, and cosine in quadrant 4. So then we talked about finding the trig functions of angles. So we found the cosine of 135 degrees. This was in quadrant 2, which made x negative over the radius, and of course our radius is 1, what we're doing right now. So the value of x at the cosine of 135 was negative the square root of 2 over 2. And then we found tangent of 390. So that's 390 degrees. So we took away 360 degrees because that's defines the coterminal angle, which gave us 30 degrees. And tangent of 30 degrees was equal to y over x, which using our terminal points, we had 1/2 over the square root of 3 over 2. And we reduced that down to either 1 over the square root of 3 or the square root of 3 over 3. So there is our tangent of 390 equal to that. So then we talked about reference angles, which are on page 494 if you weren't here last time. And we talked about finding the reference angle for theta equal to 5 pi over 3. So to find that reference angle, again, we took 2 pi and set it with a common denominator. So we had 6 pi over 3, which is the same as 2 pi, subtracted our 5 pi over 3, and got pi over 3 for our reference angle. If we wanted to find the reference angle for theta equal to 870 degrees, we went ahead and added 360 plus 360, which got us 720. Took that away from 870 and got 150 degrees. And then if we took that away from 180, we got theta bar. Remember, we had bars for the reference angles. Theta bar is equal to 30 degrees. And 150 is going to be in quadrant 2, and since it's coterminal, so would theta equal to 870 degrees. So that's what we did last time to get us kind of acquainted, and for those of you who weren't there, you now have an idea of what we did last time, so maybe you will not be quite as confused. So we are going to evaluate trig functions for any angle. On page 494 it has these instructions listed in the book, and if you want to write them, that's fine. You will find them in the book though, and I didn't want to spend the time on the video actually writing those out. So the directions that we have here for evaluating these trig functions for any angle is to find the reference angle theta, determine the sine by the quadrant. The value of the trig function of theta is the same except for the sign for trig functions of theta bar. Remember, theta bar is going to be that reference angle. So if we're finding the reference angle, and that is theta bar, let's use the reference angle to evaluate the trig functions of sine of 240 degrees. Well, the first thing we need to figure out is where is the terminal side? Which quadrant is it going to be at? So if we draw our unit circle, and we remind ourselves here we're at 0 degrees, and we're also at 360. This is 90. This is 180. And this is 270. So 240 is going to be kind of like right in here. So we know that we are in quadrant 3. And if we want to find that reference angle, the closest axis back is the negative x-axis. So if we take away 180 from 240, that will get us our reference angle. So if we take 240 and subtract 180, that will get us 60 degrees. Now, if we're talking about the value of sine of 240, and we're talking about quadrant 3, it is going to be negative. So this tells us that the sine of 240 degrees will be equal to the negative value of sine of 60 degrees. And the sine of 60 using our, this is our reference angle. If we think about what our terminal point in quadrant 1 would be for the sine of 60, and 60 is equal to pi over 3 in quadrant 1, the value of sine there is going to be negative the square root of 3 over 2. So that's you using your unit circle. You might want to have that handout handy for you to be using throughout this. Alright, so let's look at another one. What if we want to find cotangent of 495 degrees? Well, if we want to find the reference angle for the cotangent of 495, the first thing we got to do is find our reference angle. So if we subtract 360 degrees, because that's one time around, that'll get us 135 degrees. So we are coterminal with 135 degrees. So where will our terminal side be in quadrant? Which quadrant are we looking at? Well, if we go back to the unit circle we have over here with our degrees laid out, 135 is between 90 and 180. So it's going to be somewhere in here. And if that is telling us then that we have a terminal side in quadrant 2. So the reference angle, we can take 180, because that's our closest x-axis, 180 degrees minus 135 degrees, and we will get 45 degrees. Now, cotangent of 495 is going to be negative. So we can write, just like we did before, that the cotangent of 495 degrees will be equal to the cotangent of 135 degrees, which is equal to the negative of cotangent of 45 degrees. And the cotangent of 45 degrees will be the square root of 2 over 2 over the square root of 2 over 2. Because 45 degrees is going to be our pi over 4. And our reference, or our terminal point, is square root of 2 over 2, square root of 2 over 2. So this will become, you can see that they're actually equal to each other, so we really don't have to multiply by the reciprocals. We can see that that is going to be 1, because it's the same thing over itself. Remember, 1 can look like anything, and this happens to be the square root of 2 over 2, and the square root of 2 over 2. So, because we have that negative out here, we will have it equal to negative 1. Now, what if we want to do some more things with our reference angles? So we are going to use the reference angle So we're going to use the reference angle to evaluate the trig function. So let's find sine of 16 pi over 3. Now 16 pi over 3, what would that be coterminal with? Well, if I want to figure that out, I've got to think about how many pi's around is that on our unit circle. Well, if I take 16 pi over 3, let's subtract 2 pi from it. Now, 2 pi we can rewrite if 2 pi is over 1. If we want the common denominator, which here is 3, 1 times 3 would be 3, and 2 times 3 would be 6. So 2 pi is equal to 6 pi over 3. So I'm going to subtract 6 pi over 3, and because we have common denominators, I can take 16 minus 6, which will get me 10. Well, that's still quite a bit bigger than our 3 at the bottom, so let's take away another 6 pi over 3. So we've gone around twice, and 10 minus 6 will be equal to 4 pi over 3. So that tells us that sine of 16 pi over 3 is coterminal with our 4 pi over 3. So 4 pi over 3, this is 1 more than our denominator, so this tells us that is going to be in quadrant 3. Now the reference angle for 4 pi over 3 is going to be, so let's see, we have our reference angle for 4 pi over 3 is going to be what? Well, if we're thinking about that unit circle again, and we're down here at 4 pi over 3, we're going back up to that negative x-axis. So we need to subtract a pi from there. So if we subtract 3 pi over 3, because that's a whole pi, with a common denominator, we're going to get pi over 3. So our reference angle here is going to be pi over 3, and sine in quadrant 3 is negative. So if sine is negative, then that tells us that the sine of 16 pi over 3 is equal to sine 4 pi over 3, which is equal to the negative of a sine pi over 3. And the sine of pi over 3 is going to be the negative of the square root of 3 over 2. And that comes from our terminal point. All right, let's find another one. So if we want to find secant of negative pi over 4. Well, where is negative pi over 4? Remember, that tells us we're actually starting from here and going clockwise, right? So negative pi over 4 is in quadrant 4. And the reference angle will be the same thing that it is, except it'll be positive. So our reference angle is pi over 4. And secant goes with cosine, which is the x value, and it will be positive in quadrant 4. So we have secant of negative pi over 4 is equal to the positive of secant pi over 4, which will be equal to 1 over cosine, and cosine at pi over 4 is the square root of 2 over 2. So this, if we multiply by the reciprocal, will get us 1 times 2 over the square root of 2, which we could rationalize to be 2 the square root of 2 over 2. This will then cancel, the 2's will, and we'll have the square root of 2. Alright, so the next part we're going to talk about will be trig identities. And with trig identities,